Having a little look at 2012 question 6, part B. This one we have a ball on top of another ball. The small ball has a mass of m, and it's going to get a little nudge, and it's going to roll down the side of the ball. the small ball will leave the large sphere. We call this point B, and the question is to find the speed at B. There's a further question to find the horizontal distance, the distance in the eye that the ball makes after a certain time, and then to find out what a constant k is. So the first part is to find out about where B is, and we should draw the diagram for that. So here's our first sphere. This is a radius of 0.3 meters. There's another sphere on top there. The ball's going to roll down at this point, or some point B. It will fall off. We have to determine this angle alpha, and so that's what we've got to do. So there's a couple of things here. The ball will fall off when the forces, if I draw another ball here, just draw a test ball if you like. There is a weight force of this ball, and it's acting on the other sphere, so that will cause a reaction. That reaction will be 90 degrees to the tangent of the so if I resolve the weight force into two vectors, one going down, one going along, I'm going to find out that at all points the force into the circle is equal to the force out of the circle. And the force into the circle in this case is weight. Now that's alpha there, so this is weight cos alpha, and that's equal to, at all points, the force is going out. So the first force that's going out is the centripetal force, and that's mv squared over r. It can also be omega squared or but in this case we're looking for a velocity. Sorry, we're looking for a velocity here. Yes, that's right, but that's okay. If we're looking for a velocity, we should probably use the v. There's another force though, and that's the reaction force. This reaction force is the force that's coming out that balances up the forces to keep it still in contact. Okay, so that means if it's still keeping it in contact, when r goes to 0, the ball leaves. So at B, W cos alpha is equal to mv squared over r, or maybe I should go mg cos alpha is equal to mv squared over r, which means that g or cos alpha is equal to v squared. Okay, so that's at any point. Sorry, that's at B. This is true for any point. It's basically balancing the forces. Circular motion is mainly about balancing forces up and down on a horizontal plane, but always in and out in both vertical and horizontal planes. So then the other thing that we want to worry about is, where did it get its velocity? It got it from energy. So the potential energy at the top was equal to the kinetic energy plus the potential energy lower or at B. Okay, so the potential energy at the top is mgh, mg by 0.3. So if you don't mind, I can write 0.3 mg if you want, or just write 3/10, just because it's equivalent. And that's equal to the kinetic energy, excuse me, which is a half of mv squared, plus potential energy at the bottom. Again, it's mgh. This time the h is this height here. This is h2 or later, hb. So you can see that while I have an angle of this, the triangle I'm really making is here. This is my triangle that I'm really worrying about. So I want to find the height this is. So this is 0.3, 3/10 times cos alpha. That's the h times m times g. So this is equivalent, it's all the same. So get rid of my m's. Remember that I'm looking for v squared. So, sorry, I'm looking for the angle. What am I looking for? The velocity. Find the speed of the particle. Okay, well, let's rearrange it first for v squared. So v squared is equal to 2 times, that's the half cleared, (3 over 10 g) yep, times, so that's this one, 1 minus cos alpha. Yeah, I think that's right. So we have to find v squared and v squared here, so these two are equal. So I'll write it out properly, I'll write it fully. G or G, that's right. Or is 3/10. It's, I said this earlier, 0.3 of a meter. Cos alpha is equal to v squared, which is equal to 3g over 5 times 1 minus cos alpha. There's a g on both sides, I'll get rid of that. So I'm left with 3/10 of cos alpha. So 3 over 10 cos alpha is equal to 3/5. Well, let's just make it tenths to make it easier. So 6/10 by 1, 6 minus 6 cos alpha. So I can forget about that. So 3 cos alpha minus 6 cos alpha makes 9 cos alpha is equal to 6. So cos alpha is equal to 6 over 9, which in most people's words is 2 over 3. So that's cos alpha. They didn't ask for cos alpha. I did say I needed to find alpha earlier. We want to find v. Just on that now, this phrase is equal to v squared. So is this phrase. I just equalize these two to get this answer. So now we're looking for v. Well, I know that v squared is equal to, this is the easier one, 3/10 of G cos alpha, which we just said was 2/3. So there you go. So that cancels that. So 2/10, 1/5. So G over 5 is equal to V squared. I figured that out sometime, which is 1.4. Okay. Yeah, there's a second part to this. I wonder if we can get it done there. Perhaps not. We might reference. So crucially, we have the velocity in which this leaves. That's good. We have the angle also, so that's good too. What we're looking for is an equation of the distance from here to wherever, but the thing to count in fact is probably that we have some knowledge of some of the distance, so we should really deal with this as a compound distance problem. I suppose the first part of the distance problem will be, what's this? We can figure out the second part later. So we have cos alpha. Alpha is here. Cos alpha is given us this side. This is sine alpha, and that's also equal to the length of that. So if I say that this first distance, that S1, which S1 is equal to 3/10, the radius, times sine alpha. So if cos alpha was equal to 2/3, that means we have a triangle. That's 3 and 2. To find that out, it's 3 squared minus 2 squared. And get the root of that. So that's 9 minus 4. That's equal to 5. I want the root of that, so root 5. So that means the sine alpha, this is my other side, root 5. Sine is equal to opposite over hypotenuse. The opposite in this case, root 5, over the hypotenuse is the same as 3. So I've got 3 over 10 times root 5 over 3. That cancels that. That goes root 5 over 10. Okay, so back to the question. I remember seeing a root 5. So the horizontal distance in meters of the particle from the center of the sphere after it's left the surface is root 5 over 10. Okay, so that's that bit done. Okay, so actually all I'm looking for is this bit. So that's that bit done. I've got the root 5. That solves half the problem. Now all I'm saying is this here is KT. So I need to get a phrase in T. I'm not finished with this diagram at all. What I'm looking for is the velocity that's going in this direction. So we've been told, we just calculated that the velocity here is 1.4. Whatever velocity it has at this very moment in time in the I direction will be maintained, as there's no acceleration in the I direction. So need to have a little look at my angles here. If that's alpha, well then this one's alpha. If that's alpha, that's not. It's a right angle. This one is. So we're back to velocity. The side that I'm looking for is this green side. Can you see this? This angle here is alpha. That means that's the cos of it. So the V in I is equal to 1.4, that's the total velocity, times cos alpha. So that's 1.4 times 2/3. It only matters at the time of launch. and that's 14/15. So the velocity is fine. They didn't ask us for the velocity, they asked us for the distance, and distance is equal to vt, velocity by time. So therefore it's 14/15t. Let's just check back at the question. So it's root 5, so the total distance s1 plus s2 is equal to root 5 over 10 plus kt. We think that that's 14/15t. Perfect. Find value of k to 2 decimal places. 0.93 is equal to k.